Hi everyone, this is Simon Ray with METTLER TOLEDO. I'm a Principal Technology and Applications Consultant, and I'm just going to give a quick technology update, and we're going to have some focus on the newly released RC1mx. So there's certain steps to process understanding. So when scaling up from lab to plant, there are certain parameters we need to understand. Things like the heat transfer coefficient and heat capacities, enthalpy, which is what we do with the RC1, the maximum heat removal rate of the plant or the large vessel, so we need to work within those constraints. We need to optimize dosing and reaction times to make sure that they are amenable to the plant scale. Things like mixing, mass transfer, and of course the kinetics. If we can understand all these aspects, we have a better chance of doing a successful scale-up. Now, early on, we'd also like to understand what some of the safety hazards that we might encounter, and we'd like to try to find these as early as possible. So at smaller scale, we'd like to identify if there's going to be some sort of safety or scale-up issue. Things like delayed initiation, accumulation of unreacted material, the enthalpy and the heat removal rate behavior of that enthalpy as it comes out of the reaction, things like heat spikes, and any autocatalytic behavior. We'd like to understand that at the small scale so we can eliminate those sorts of parameters early on. As we move further along with our scale-up study, we need to do a full study for process safety. Things like thermal conversion and thermal accumulation we need to understand, the adiabatic temperature rise and the MTSR. Things like time to maximum rate. Is there a potential of triggering a secondary decomposition reaction with our particular process? Probability of a failure and the criticality class of that reaction. Now, why do we perform reaction calorimetry? As we scale from lab to plant, there is always going to be some sort of scalability problem that may suddenly emerge for a variety of reasons. The causes of thermal incidents are often caused by just the lack of understanding of the process thermochemistry. The heat removal rate that we require for this particular process might be more than what the plant can handle. Just not understanding the mixing well enough and expecting what mixing we can achieve in the lab will also be achieved in the plant. And also human factors. We're dealing with humans, operators that are working at the large scale, and mistakes can be made, and sometimes these can impact our process. Now, we really need this sort of data at the lab scale to understand what these sorts of things might actually impact at large scale. So we need to do these things under process-like conditions with sensitive reaction calorimetry, because often that energy that comes out of a reaction at lab scale is greatly exaggerated as we move to bigger and bigger vessels. So we really need to do this accurately so we can apply what understanding we have in the lab to the plant scale. So reaction calorimetry provides a high level of process understanding so that the necessary procedures can be performed routinely, robustly, and to the required standard of quality at manufacturing scale. Now let's introduce the RC1mx. This is based upon the RC1E and before that the RC1 Classic. This technology has been around for many decades now by METTLER TOLEDO, and it is really the most accurate and comprehensive calorimetric data that is on the market. The software is intuitive. It's working with our iControl software that has been around for about nearly a decade now. Intrinsically safe operations based upon the software and hardware. And it's really designed for data collection and analysis, not just for safety, but for optimization and scale-up. So the RC1mx runs our latest version of iControl software, version 6, with the optional IC safety for advanced risk assessment studies. It has the same powerful thermostat as we had with the RC1E, capable of incredible cooling capacity. There is extra safety lights now, so we can see if the status of the instrument, if it's in an error state, or if the power has been turned off. We can see that from a distance. We now use plug-and-play sensors for the TR sensor and the calibration heater, as well as other devices that are connected to the system. Now we can use touchscreen control, the same kind of control we have on our EasyMax, which allows local control in case the PC is further away from the instrument. The stir motor is exchangeable for higher torque type applications. And again, the Smart Connect technology, where we have this plug-and-play probes, plug-and-play devices, and so on, which are self-recognized by the system. As mentioned earlier, we have the same powerful heat removal that we had with the RC1E, but now we have just one system. We don't have what we used to call the low temp, mid temp, and high temp options. Now it's just one option, and to change the range of temperature, if you wanted to go from the low temp range from -70 to 80 up to, say, the high temp from 0 to 300 C, all you do is change the oil. So the hardware doesn't have to be changed. And again, we have this large pre-cooled oil sitting in a reservoir at the bottom of the instrument, which is always ready for maximum responsiveness in case there is a large exotherm or the cooling needs rise very quickly. IC Safety is an option found within iControl software and follows Professor Stossel's from the Swiss Institute of Safety's guidelines for creating full report for safety. It'll show criticality graphs, the runaway graph, and it combines data from the RC1 run along with data found from a DSC or ARC or other microcalorimetry device, and it allows you to adapt the design of the process, taking the required safety measures, making processes robust against maloperation. Now, why is the RC1mx a solution for process safety and scale-up? First of all, we need to understand all the process and reaction parameters at lab scale. So we need accurate reproducible data for scale-up and safety investigations, and the impact of individual parameters may have on the process. So we really want to determine and eliminate scalability risks early on in our study. We can explore the processes safely. The thermostat, as mentioned before, is super powerful for cooling and can pretty much encounter any chemistry without issue. Copes with fast and strong exotherms, can explore unknown process conditions without exposing the operator or lab to any danger. We want to understand the true heat of reaction, so the data needs to be reliable and trustworthy. The complete heat of reaction versus a profile of heat removal, and evaluate the risk, the scalability, and criticality of a process. Supports a determination of kinetics of reaction. Now, the iControl software automatically provides and evaluates experimental data, simplifies analysis with the IC Safety, and allows you to create reports with one click. Now, the three aspects to the solutions for process understanding, we talked about scale-up and process safety early on studies all the way to full studies. METTLER TOLEDO provides various instruments that have a role in each of these different aspects. The Optimax and the RC1, of course, can do scale-up and optimizations. Early on screening for scalability risk would be the EasyMax, where you want to run at smaller volumes. And then the full-scale study would be the RC1mx, along with a microcalorimeter such as a DSC. Now, to learn more, we can provide an on-site seminar. We have online resources found on mt.com, and there's videos as well that can be found simply by searching the culture of safety on our website, or just follow the web address below.